Welcome back to The Deep Dive. Today we're tackling, well, a giant. Albert Einstein. His name, his face, they just scream genius, right? But the real story behind Ibn Siyafat, it's so much more complex, more revolutionary, and definitely more human than just that iconic image.
It's absolutely right. That's the goal here. Einstein didn't just tweak physics. He fundamentally rewired how we understand existence itself. Space, time, the whole energy-matter connection. What we need to explore today is how that incredible scientific mind was tangled up with a pretty turbulent personal life, and eventually how he became this global moral voice.
Exactly. We're going beyond the wild hair and the tongue photo. We're tracing his whole journey from this curious kid in Germany who was actually slow to talk through that unbelievable Annus Mirabilis' miracle year and right up to his time as this kind of skeptical sage in Princeton.
Yeah, covering the breakthroughs, the theories, obviously, but also his clash with the Nazis, his exile.
And why he later called that famous letter about atomic research his one great mistake. Okay, let's get into it. Okay, so to really get Einstein the revolutionary, we have to start at the beginning. He was born in Ulm, back when it was the German Empire, 1879. His parents, Hermann and Pauline Einstein, were secular Ashkenazi Jews. His dad was a salesman, kind of an engineer too, right?
Yeah, he and Albert's uncle, they were entrepreneurs. They moved the family to Munich fairly early on to start a company.
Ah, the family business.
Right. Elektrotechnische Fabrik, J. Einstein and C. And this is actually pretty important context because the business ultimately failed, which had big consequences later. They were focused on DC, direct current electrical gear.
Okay, DC, but the world was shifting.
Exactly. Towards the end of the 1800s, AC, alternating current, think Westinghouse, Tesla that was taking over, their DC tech was becoming obsolete.
So they bet on the wrong horse, basically.
Pretty much. They couldn't land the big city contracts, and the company went under around 1894. That forced the family to move again, this time to Italy, Milan. Then Pavia, looking for, well, a fresh start. This early brush with technological change and money troubles, it definitely stuck with young Albert.
And it's in this childhood period we see those fascinating contradictions, like his parents actually worried he might have a learning difficulty because he was so slow learning to speak.
Yeah, it's almost hard to believe now.
But then there's that story, the one that feels almost too perfect, when he's 5 years old, sick in bed.
The compass. His father gave him a simple pocket compass. And for little Albert, seeing that needle just move consistently, pulled by some invisible force, magnetism, it was like a bomb went off in his head.
It wasn't like things being pushed or pulled directly.
Right. It wasn't mechanical. It made him realize, as he put it later, that something deeply hidden had to be behind things. That mystery, that invisible force, it lit the fuse for his lifelong obsession with understanding nature's hidden rules, especially electromagnetism. That compass moment really echoes through his whole career.
Okay, so then formal schooling in Munich at the Luitpold Gymnasium, that seems less magical than the compass. He wasn't exactly a model student, was he?
No, definitely not. He famously chafed against this strict, almost military-style rote learning there. He found it stifling, counterproductive.
He thought it killed creativity.
Absolutely. He held that view his whole life, that kind of forced authority, the endless memorization. He felt it just crushed the natural curiosity that fuels real learning. You can kind of see the seeds of his later anti-authoritarian streak there,
Yet while he's fighting the system, he's also, secretly becoming a genius on the side.
Sort of, yeah. By the time he was 12, he was teaching himself things like algebra, calculus, Euclidean geometry. There's this anecdote, maybe slightly exaggerated but indicative, that before he was even 13, he didn't just learn the Pythagorean theorem, he came up with his own original proof for it.
Wow. Okay. That's advanced.
It's incredible speed.
Huh.
But maybe even more important than the math was the philosophy he was getting into around that time. His tutor, a guy named Max Talmud, gave him Kant's critique of pure reason when he was 13.
Kant? At 13? That's heavy stuff.
It is, but it seems to have clicked with him. Kant's ideas reinforced his own gut feeling that the universe wasn't random chaos, that it followed these deep rational laws that the human mind could figure out. He got this really strong conviction early on that nature was ultimately a mathematical structure. That confidence drove him, even when things seemed confusing later.
But that friction with formal education, it didn't just disappear. In 1895, he's 16, tries to get into the big polytechnic school in Zurich, the ETH.
Right, but he fails. Well, fails the general knowledge part, the physics and math sections. He apparently aced those completely.
So a bit uneven.
Definitely. He had to go finish his secondary school somewhere else, in Aarau, Switzerland, before he could finally get into the ETH later. But right around this time, he makes a really huge decision about who he is. In 1896, he's 17, and he formally gives up his German citizenship.
He renounces his citizenship. Why?
With his father's okay, apparently. The main reason was to avoid being drafted into the German army. Compulsory military service. He wanted no part of it.
And he became Swiss instead.
Yeah, he got his Swiss citizenship in 1901. And that was it. He was done with the German state, at least officially.
Yeah.
He kept that Swiss citizenship his whole life, even after moving to America.
So when he finally gets into the ETH, the teaching diploma program, he starts connecting with people who get him.
Yeah, peers were crucial. He became good friends with Marcel Grossmann, who wasn't just a buddy, but later provided the heavy-duty math, Riemannian geometry that Einstein needed for general relativity. He couldn't have done it without Grossmann's help with the math.
And then there was Mileva Maric.
Right. His classmate, the only woman in their physics cohort, from Serbia. They clicked intellectually, talked science constantly, apparently complained about their professors together.
And it became more than just study partners.
Yes, it developed into a romance. They were intellectual equals in many ways. Now, this relationship, it's been debated by historians for ages. How much did she actually contribute scientifically to those amazing papers he published in 1905?
The Annus Mirabilis papers.
Exactly. Their letters show they discuss everything, but the exact breakdown of who did what. It's still murky. What the letters do reveal, sadly, is the start of his complicated personal life. They had a daughter, Liesl, born in 1902, before they were married.
And what happened to her?
It's tragic and unclear. Mileva went back to Switzerland without the baby. Liesl was either given up for adoption or possibly died very young from scarlet fever. We just don't know for sure. It casts a shadow, doesn't it?
Okay, so Einstein graduates in 1900, degree in hand, but finding a teaching job, not so easy. Apparently, he'd rubbed some professors the wrong way.
Yeah, he struggled for a couple of years. It was tough. Then finally, in 1902, he lands a job, but not in academia. He becomes an assistant examiner at the patent office in Bern, Switzerland. And that was thanks to his friend Grossmann's father pulling some strings.
The patent office years? This sounds like a detour. Stifling.
You'd think so. Here's this potential genius reviewing applications for, like, gravel sorters and electric typewriters, mundane stuff. But actually, it was maybe the best thing that could have happened.
How so?
Well, the job forced him to think really clearly about the practical side of physics, especially in mentions dealing with synchronizing clocks, sending signals,
Yeah.
very concrete problems.
Wait a minute. Synchronizing clocks in different places? That sounds suspiciously like...
Exactly. The seeds of special relativity were right there in his day job. The patent office wasn't a prison. It was his laboratory for thought experiments. And he wasn't isolated intellectually either. He formed this little group, the Olympia Academy, with some friends.
Catchy name.
Yeah, a bit ironic. They'd meet and just chew over the big ideas from thinkers like Poincaré, Mach, Hume. It was like his own private, super intense seminar, a real intellectual pressure cooker.
And then, boom, 1905. The Annus Mirabilis, the miracle year. He basically drops a series of bombs on classical physics, publishing 4 papers in the Annalen der Physik.
4 papers that just changed everything, all from this patent clerk basically in his spare time. You've got 1, the photoelectric effect arguing light isn't just a wave, it comes in little packets, quanta, later called photons. 2, Brownian motion, he mathematically nails down the jerky movement of particles in liquid, providing really solid proof of the existence of atoms and molecules, which some people still doubted. 3, special relativity, fixing that big conflict between electromagnetism and old-school Newtonian mechanics. And 4, the mass-energy equivalence paper, which gives us Imancy-Chadel, the most famous equation in the world. Just unbelievable output.
Let's dig into special relativity a bit. That paper on the electrodynamics of moving bodies, it tackled this fundamental problem in physics, right?
Yeah, huge contradiction. Maxwell's equations for electricity magnetism showed that the speed of light, cc, is constant. Doesn't matter if you're moving towards the light source or away from it, you always measure the same speed. But Newtonian physics, the bedrock for centuries, said speed should add up. If you're on a train throwing a ball forward, the ball's speed relative to the ground is its speed relative to you plus the train speed. Newton said the same should apply to light. If you chase a light beam, it should look slower to you.
But Maxwell said no.
Exactly, contradiction. So Einstein comes along and says, basically, Maxwell's right about the constant speed of light, which means Newton has to be adjusted.
So the speed of light is absolute, the ultimate speed limit.
Yes. And if that's fixed, then other things we thought were fixed, like space and time, they have to be flexible relative They can stretch and shrink depending on your motion. This completely got rid of the need for that weird, invisible, luminiferous ether that physicists have been searching for to carry light waves. It just wasn't necessary anymore.
And this leads to those weird counterintuitive ideas like time dilation and length contraction.
Precisely. If you're watching someone zoom past you at near light speed, their clock will appear to you to be running slower than yours, and they'll appear shorter, kind of squashed, in the direction they're moving. These aren't just mathematical tricks, they're real physical effects, though you only really notice them at incredibly high speeds. It fundamentally changed the rules of motion.
Now, it's a common misconception, isn't it, that Einstein got the Nobel Prize for relativity?
It is. He actually won the Nobel Prize in Physics for 1921, awarded in 1922, specifically for discovering the law of the photoelectric effect.
Why not relativity? Was it still too controversial?
Pretty much. Even in the early 1920s, general relativity, his theory of gravity, was still viewed with a lot of skepticism by some physicists. It was just so radical. But the photoelectric effect, that was different. It explained a specific, puzzling experimental result.
Which was?
Scientists knew that if you shine light on certain metals, sometimes electrons get kicked out. The weird thing was, making the light brighter didn't necessarily help. What mattered was the color of the light, its frequency.
So dim blue light could work, but bright red light wouldn't.
Exactly. Classical physics, thinking of light purely as a wave, couldn't explain that at all. Einstein's idea that light energy comes in these discrete packets, photons solved it beautifully. Only a photon with enough energy, which means high frequency like blue light, could knock an electron loose. A low-frequency photon, like red light, just didn't have the individual punch no matter how many of them you threw at the metal.
And this was a huge step for quantum theory.
Foundational. It showed that light itself had this particle-like quality. And his quantum contributions didn't stop there. He worked with Satyendra Nath Bose, an Indian physicist, on what's now called Bose-Einstein statistics.
What did that describe?
It described the behavior of a certain class of particles, bosons. And their work predicted this bizarre state of matter called a Bose-Einstein condensate, where particles kind of merge into one quantum state at super low temperatures. It was purely theoretical then.
But they actually created it eventually.
Yeah. Experimentally confirmed in 1995. Amazing foresight. Plus, another paper from 1917 introduced the ideas of spontaneous emission and stimulated emission of radiation. That's the core physics behind how lasers and masers work. So yeah, huge quantum contributions.
Okay, so after 1905, the academic world finally starts paying attention. His career picks up steam.
Right. No more patent office. He starts getting university jobs, junior posts, then associate professor, full professor, University Bern, Zurich, Prague, then back to the ETH in Zurich. He's moving up.
But the really big move was to Berlin in 1914.
That was the pinnacle, really. Max Planck and Walter Nernst, huge names in German physics, basically recruited him heavily. They offered him a professorship at the Prussian Academy of Sciences and Humboldt University.
What was the catch?
No catch. In fact, the offer was better than usual. It came with basically no teaching obligations, just pure research time. For Einstein, who wasn't always thrilled with teaching, that was irresistible. Plus, his girlfriend, soon to be his second wife, Elsa, lived in Berlin. So, personal reasons too.
And it's in Berlin that he finishes his masterpiece, General Relativity.
Yes, between 1915 and its publication, special relativity dealt with constant speed. General relativity tackled the big one, gravity and acceleration.
And he completely flipped the script on gravity. Newton saw it as a force pulling things together instantly across space.
Einstein saw it as geometry, warped space-time. He said massive objects don't pull on things, they curve the fabric of space-time around them, and other objects just follow those curves, like a bowling ball on a trampoline making a dip that a marble rolls into. He needed some seriously advanced math for this that Riemannian geometry Grossman helped him with, to describe this four-dimensional curvature.
And the theory immediately explained things Newton couldn't.
Yes. The most famous example was the orbit of Mercury. There was this tiny weird wobble, a precession in its orbit, that astronomers had puzzled over for centuries. General relativity predicted it perfectly. That was huge validation.
But the real clincher, the thing that made him a global superstar, was the eclipse prediction.
Right. The theory predicted that gravity doesn't just affect objects. It affects light, too. Starlight passing near a massive object, like the sun, should get bent by the sun's gravity warping space-time.
So how do you test that?
You need a total solar eclipse, so the sun's glare is blocked out, and you can see the stars near its edge. In 1919, Sir Arthur Eddington led expeditions to observe an eclipse. And the starlight was bent, exactly as Einstein predicted. The results were announced, and it was like a thunderclap. Front-page news everywhere, the New York Times, the Times in London. Banner headlines basically saying, "Revolution in science, Newton overthrown."
Wow. Just like that, he becomes the most famous scientist on Earth.
Instantly. A household name.
Oh.
Even if people couldn't grasp the physics, they knew this guy Einstein had done something monumental. He became this global icon, really the first celebrity scientist in that modern sense.
So Einstein achieves this incredible fame, but it coincides with really turbulent times, especially in Europe after World War I. And he wasn't someone who just stayed in his scientific bubble.
Not at all. His political conscience was already clear. Back during World War I in 1914, while he was in Berlin, most prominent German intellectuals signed this jingoistic document, the Manifesto of the 93, supporting the war effort. Einstein refused. Instead, he signed the anti-war manifesto to the Europeans. He stood apart early on.
His pacifism, his Jewish background, his international fame, that must have made him a target as things got worse in Germany.
Absolutely. He was a perfect symbol for the rising nationalist and anti-Semitic movements to attack. He represented everything they hated: internationalism, intellectualism, Jewishness.
And then 1933 happens.
Yeah, the turning point. He was actually visiting the U.S. at Caltech when Hitler came to power in January 1933. The news from Germany, the immediate brutal persecution of Jews. He knew instantly he couldn't go back. He decided right then not to return to his prestigious post in Berlin.
The Nazis didn't exactly roll out the welcome mat, did they?
Far from it. It was terrifyingly fast. By March 1933, when he arrived back in Europe, landing in Belgium, he went straight to the German consulate and formally renounced his citizenship again. Back home, the Gestapo raided his apartment, the state seized and sold his beloved sailboat, and they turned his summer cottage into a Hitler youth camp. Pure vindictiveness.
And intellectually, they tried to erase him.
Completely. His books were burned in those infamous Nazi book burnings. Goebbels declared Jewish intellectualism is dead. It was systematic cultural destruction.
And it got personal and dangerous.
Extremely. There was a German magazine that published a list of enemies of the state, and under Einstein's picture it said something like, "Not yet hanged." They even offered a bounty, $5,000 for him. He later told friends he was genuinely shocked by the sheer savagery and, frankly, the cowardice of many of his former colleagues who just went along with it.
So he's now a refugee, a very famous one, but still stateless for a bit. How did he find his way?
He got help from organizations set up to rescue academics, like the Academic Assistance Council. He had temporary stays, first in Belgium, then a short time in England. He was hosted there by a British MP, Commander Locker Lampson. That's actually when he met Winston Churchill and pleaded with him to help get other Jewish scientists out of Germany.
But his long-term home became Princeton, New Jersey.
Yes. He got an offer from the brand new Institute for Advanced Study in Princeton. It accepted him in 1933. IAS was designed as this pure haven for scholars. No students, no classes unless you wanted them, just research. It was perfect for him. He stayed there for the rest of his life until he died in 1955.
And he eventually became an American citizen.
He did, in 1940, along with his secretary Helen Dukas and stepdaughter Margot. And he seemed to genuinely appreciate certain aspects of American culture. He often spoke about the freedom here, the right to say and think what they pleased, as he put it. He felt that openness led to more creativity.
But he wasn't blind to America's problems.
Not at all. He was deeply disturbed by the racism he saw. He became a member of the NAACP and was very outspoken, calling racism America's worst disease. He saw it a fundamental flaw in the society. And he didn't just talk about it. There's that great story about Marian Anderson, the famous black opera singer.
What happened?
In 1937, she came to Princeton to perform, but was denied a room at the local Nassau Inn because she was black. Segregation was rife. When Einstein heard about it, he immediately invited her to stay at his house. It was a quiet but powerful statement against the prejudice of the time. He hosted her whenever she came back to Princeton after that.
Okay, let's get to that huge political paradox.
Yeah.
The pacifist and the bomb. The Manhattan Project letter.
Right. This is probably the most complex part of his political life. In 1939, World War II is looming. Two fellow refugee physicists, Leo Szilard and Eugene Wigner, both Hungarian Jews who understood the physics, became terrified that Nazi Germany might be developing an atomic bomb.
And they needed Einstein's influence.
They knew only his name carried enough weight to get the U.S. president's attention. They went to see him out on Long Island, explained the potential for a nuclear chain reaction, the possibility of unbelievably powerful bombs, and they persuaded a very reluctant Einstein to sign a letter to President Franklin D. Roosevelt.
What did the letter say?
It warned FDR about the German research and strongly recommended that the U.S. start its own nuclear research program immediately, just in case.
And that letter is often seen as the catalyst for the Manhattan Project.
It's widely credited with kickstarting the U.S. effort, yes. For Einstein the pacifist, this must have been pure agony. He only signed it out of this terrible fear, the fear that Hitler would get the bomb first. That was the only justification in his mind.
And he came to regret it deeply.
Profoundly. Especially after Hiroshima and Nagasaki. Later in life, he told Linus Pauling, another Nobel laureate and peace activist, "I made one great mistake in my life when I signed the letter to President Roosevelt recommending that atom bombs be made." She felt complicit, even though he had no direct role in the project itself. His name just opened the door.
So his later activism was very focused on nuclear disarmament.
Very much so. In 1955, just before he died, he signed the Russell-Einstein Manifesto with Bertrand Russell, warning humanity about the existential threat of nuclear weapons. He co-founded the World Academy of Art and Science. He saw the danger clearly.
And his broader political vision.
He became a strong advocate for some kind of world government, a global federation. He thought nationalism and unchecked nation-states were the root cause of war, especially in the nuclear age. He said there was no other possible way to eliminate the danger. He also openly favored democratic socialism, writing an essay called Why Socialism, and he greatly admired Mahatma Gandhi's nonviolent resistance.
What about Zionism in Israel? Who had connections there?
He did. He was instrumental in fundraising for and establishing the Hebrew University of Jerusalem back in the 1920s. But he wasn't a political nationalist. He was actually quite critical of the idea of creating an independent Jewish state with borders and an army. He favored binational cooperation with Arabs. Later, in 1952, after Israel was founded, they offered him the presidency a largely ceremonial role. He declined. He said he was deeply moved, but also saddened and ashamed that he couldn't accept, citing his age and, implicitly, his reservations about nationalism.
Okay, let's zoom out and look at the sheer impact. Scientifically, it's hard to overstate. You've got general and special relativity, EMC, the whole photon concept from the photoelectric effect, Bose-Einstein statistics. These aren't just historical footnotes. They're the bedrock of modern physics.
Absolutely. General relativity, for instance, isn't just something studied in history books. It's actively used every single day by astrophysicists and cosmologists. You can't understand black holes, gravitational lensing, the expansion of the universe, the Big Bang. None of it makes sense without GR as the framework.
But then there's the thing he spent the last decades of his life on, mostly in Princeton, that he didn't crack, the unified field theory.
Right. His great unfinished quest. After establishing relativity, covering gravity, and contributing so much to quantum theory, covering electromagnetism and later the nuclear forces, he became obsessed with finding a single mathematical framework, a single master equation that could unite all the fundamental forces of nature. Specifically, he focused on unifying gravity and electromagnetism geometrically.
Trying to find the ultimate theory of everything.
Pretty much. He published several attempts, worked tirelessly on it, but he never got there. The problem turned out to be much harder, especially once the strong and weak nuclear forces were better understood. They didn't fit neatly into his geometrical approach.
So a failure in that sense.
A personal failure for him, maybe, but hugely influential. His dream of unification, even though his specific path didn't work out, is still the driving force behind huge areas of theoretical physics today. String theory, quantum gravity research, it all stems from that same ambition Einstein championed. His failure pointed the way for everyone else.
And we shouldn't forget he was also an inventor, in a way.
Yeah, he wasn't just chalkboards and equations. He collaborated on experiments, like the Einstein to Haas experiment, which physically showed a link between magnetism and the spin of electrons. And he teamed up with Leo Szilard again, oddly enough, to invent and patent a novel type of refrigerator.
Refrigerator?
Yeah, the Einstein-Szilard refrigerator. It used an absorption process with only a heat source, no moving parts, no noisy compressor. It was designed to be super reliable and safe after they read about a family killed by toxic fumes leaking from a conventional fridge pump. It never really took off commercially back then, but the principles are still relevant. Beyond the pure science, his thinking, even his disagreements, profoundly shaped physics and philosophy. His biggest intellectual battle was probably with the implications of quantum mechanics as it developed after 1925.
This is where God does not play dice comes in.
Exactly. He fundamentally objected to the inherent randomness and probability that seemed baked into quantum theory, championed by people like Bohr and Heisenberg. He couldn't accept that the universe, at its deepest level, operated on chance. He felt quantum mechanics, while successful at predicting results, must be incomplete, a stepping stone to a deeper deterministic theory.
And that led to the EPR paradox.
Yes. In 1935, with his colleagues Boris Podolsky and Nathan Rosen, they devised this brilliant thought experiment, the EPR paradox, designed to show that quantum mechanics led to absurd consequences.
What was the absurdity?
It highlighted quantum entanglement. If two particles are created together in a certain way, they remain linked or entangled. Quantum mechanics says if you measure a property of one, like its spin, the other particle instantly knows and takes on a correlated state no matter how far apart they are, miles, light years, doesn't matter.
Instantaneous connection across space.
Yeah, what Einstein called spooky action at a distance. He argued this violated the core principle of relativity, that nothing, not even information, can travel faster than light. Therefore, he concluded, quantum mechanics must be missing something. There must be hidden variables determining the outcomes locally.
But history proved him wrong on that.
Ironically, yes. Experiments, especially since the 1980s, with the Lane aspect and others, have repeatedly confirmed that this spooky action is real. Entanglement is a fundamental feature of reality. And the very paradox Einstein created to disprove quantum mechanics' completeness is now the absolute bedrock of fields like quantum computing, quantum teleportation, quantum cryptography. His attempt to find a flaw became a cornerstone.
That's incredible. What about his views on religion and God? He talked about it often, but it seems complex.
Very complex and often misunderstood. He wasn't religious in any traditional sense. He felt a deep connection to Spinoza's idea of God, an impersonal God who is the rational order and harmony of the universe, not a personal God who answers prayers or intervenes in human affairs.
So more awe at the universe's structure.
Exactly. He called himself a deeply religious non-believer, or sometimes an agnostic. He wrote quite bluntly that the word God was just the expression and product of human weaknesses. But at the same time, he spoke of a spirit vastly superior to man's, revealed in the laws of the universe. He worshipped the understandability, the mathematical elegance of nature itself.
And music played a big part in that sense of harmony for him, didn't it?
Oh, hugely. Music wasn't just a hobby. It was essential to his way of thinking. He played the violin pretty seriously his whole life. Loved Mozart and Bach especially. He famously said if he hadn't been a physicist, he probably would have been a musician. He felt there was a deep connection between the structure and beauty in music, and the structure and beauty he sought in his physical theories. It helped him think, apparently.
So after 1919, after the eclipse results, he's not just a scientist anymore. He's a global phenomenon.
Unprecedented, really. He was instantly recognizable everywhere. People might not have understood relativity at all, but they knew his face, his name. He became the archetype.
The absent-minded professor.
Totally. The wild hair, the kindly but penetrating eyes. He became synonymous with genius. That image is so ingrained. Time magazine naming him Person of the Century in 1999 just solidified that status.
And that one photo, the tongue picture.
Yeah, the famous one. Taken on his 72nd birthday in 1951 by photographer Arthur Sass. Apparently, photographers were pestering him to smile, and he just got tired of it and stuck his tongue out instead.
It kind of captures his playful side, his refusal to be overly serious despite everything.
Exactly. It became this iconic image of irreverent genius, and his legacy is literally written onto the map and the periodic table. There's the element Einsteinium, named posthumously in 1955. There are mountains named after him in Alaska and New Zealand. He's part of the cultural landscape in a way very few scientists ever achieve.
What's amazing is how relevant his work still is. Things he predicted are only now being confirmed decades later.
Gravitational waves are the perfect example. He predicted these ripples in spacetime back in 1916, a consequence of general relativity. People looked for them for decades, found indirect evidence. But the first direct detection by LIGO wasn't until 2015, announced in 2016, almost exactly 100 years after the prediction. It opened up a whole new way to observe the universe.
And his cosmological constant, the term he added to make the universe static.
Right, the one he supposedly called his biggest blunder after Hubble showed the universe was expanding. Well, the story's more complicated, but the cosmological constant itself has made a huge comeback.
How so?
In the late 1990s, astronomers discovered the expansion of the universe is actually accelerating. And the best explanation for that mysterious acceleration involves something very much like Einstein's cosmological constant, now often linked to the concept of dark energy. So his blunder might actually be pointing towards a fundamental property of the cosmos.
And that forgotten paper from 1931 you mentioned.
Yeah, the one discovered recently where he explored a kind of steady-state expanding universe before the Big Bang model really took hold.
Yeah.
It just shows how constantly he was thinking, exploring alternatives, even models that didn't pan out in the end. He wasn't dogmatic.
And we already talked about the EPR paradox, how his attempt to disprove quantum weirdness ended up highlighting entanglement, which is now key to quantum tech.
It's a recurring theme.
Mhm.
Even his criticisms and wrong turns were incredibly fruitful for physics down the line. And just as a side note on experiments, that Einstein to Haas experiment from 1915, the only one he really conceived and carried out himself, they actually rediscovered the original apparatus recently in 2023. A little piece of history found again.
Looking back at his life, what lessons stand out? Oppenheimer's description of him, wonderful purity, childlike and profoundly stubborn, seems to capture something essential.
I think it does. There was a moral core there. His life really underscores the idea that science doesn't happen in a vacuum. It has social responsibilities. You see it in his tireless work helping fellow scientists escape the Nazis, his very public stance against racism in the U.S., his warnings about nuclear war. He believed scientists had a duty to speak out, to serve humanity.
And his own educational struggles seem relevant too.
Definitely. His critique of rote learning, his emphasis on understanding and curiosity over just memorizing facts, that's a message that still resonates today, doesn't it?
Yeah.
He believed education should nurture that innate desire to figure things out, not crush it.
He embodied the power of thinking differently.
Absolutely. He showed you don't necessarily need the establishment's approval or the fanciest equipment to have revolutionary ideas. You need the courage to question assumptions, to follow your curiosity, even if it leads you down unconventional paths. That patent office clerk changing the universe. It's an incredible story of intellectual independence.
His whole philosophy seemed rooted in finding joy in learning. That idea that love is a better teacher than a sense of duty.
Yeah, that natural curiosity was his engine. It's what drove him to teach himself advanced math as a kid, what made him connect physics to his violin playing, what kept him asking those fundamental why questions his whole life. He inspires us to keep asking those questions.
And his standing among physicists, it's pretty much unique.
It really is. There's that informal ranking scale attributed to the Soviet physicist Lev Landau, where genius is ranked logarithmically. Newton is maybe a 0, the absolute peak. Landau put Einstein at 0.5. Almost nobody else comes close in that system. It just highlights the sheer scale of his impact across multiple areas of physics.
And that final, slightly macabre detail about his brain.
Right. After he died in 1955, the pathologist performing the autopsy, Thomas Harvey, removed his brain without the family's full permission, hoping it could be studied later to find the biological basis of his genius.
Did they find anything?
Studies over the years have suggested some unusual features, different proportions in certain areas, maybe more glial cells, but nothing conclusive that says, this is why he was Einstein. It remains this symbol, though, of our enduring fascination with the mystery of intelligence and creativity.
So we've followed Albert Einstein's incredible arc, from that curious, quiet kid in Ulm through the breakthroughs that reshaped physics, becoming this unexpected global icon, then an exile, a moral voice wrestling with the consequences of science in the atomic age. His legacy isn't just the equations, it's the profound, sometimes uncomfortable questions he forced us to ask about the universe and our place in it.
Absolutely. And what's striking is how he kept evolving. His scientific views changed, his political stances developed, his philosophical ideas deepened over time. Even his famous failures, like not finding the unified field theory or his initial resistance to quantum randomness, they weren't dead ends. They actually mapped out challenges and directions for generations of physicists who came after him.
So here's a final thought for you to mull over, something maybe a bit strange. After Einstein died, he was cremated, and his ashes were scattered secretly at an undisclosed location. The man who gave us the coordinates for space-time, who mapped the universe, chose to leave no fixed coordinates for himself in the end. What does that final act, that kind of deliberate erasure, tell us about how he viewed his own legacy? Something fluid, maybe not fixed.
It's definitely something to think about. We'd encourage you, if you're interested, to explore his writings beyond the science, his essays like Why Socialism, his letters, or maybe just listen to some Mozart or Bach, the music that gave him so much joy and inspiration, and ponder that connection between harmony and the cosmos he sought so relentlessly.